Hello everyone. In this video, we are going to learn the derivation for balance condition of Wheatstone Bridge. Okay, so let's start. What is Wheatstone Bridge? Actually, it is a device in which four resistors are connected in the form of a quadrilateral. Okay, and when the bridge is balanced, okay, that is current through the galvanometer is 0, then R1 by R2 is equal to R3 by R4. So that derivations will be asked for 3 marks in the board examinations. So you can see A, B, C, D is a quadrilateral. In that R1, R2, R3 and R4 resistors are connected. Okay, across one end diagonally, okay, across BD you can see galvanometer is connected having resistance G. So what is the condition? Current through the galvanometer is a 0. Ig is what? 0. That is the condition of Wheatstone bridge. Then R1 by R2 is equal to R3 by R4. You can see here it consists of 4 resistors R1, R2, R3, R4 connected in the form of a quadrilateral. And a cell of EMF E is connected across the A and C. You can see a cell is connected of EMF E. And a galvanometer of resistance capital G is connected across B and D. Okay. So if the four resistances are varied such that the current through the galvanometer is, that is Ig is 0, the Wheatstone bridge is said to be electrically balanced. The condition is what? R1 upon R2 is equal to what? R3 upon R4. We are going to do the derivation for this. So let's do the derivation. You can see same diagrams A, B, C, D quadrilateral having resistances. This is what? R1, this is R2, this is R3 and this is R4. So now when the cell is E, let's take current I, it is there from the cell E. Here current will divide here. This current is what? I1. Current through R1 is I1. Current through R2 is what? I2 you take. Now again here you can see the current divides in this branch and this branch. Current through galvanometer you take Ig. Current through R3 is what? I3 you take. Again you can see this is I2 and Ig coming at this node or junction D. Here this current is leaving. Let's take this current is I4 as it is the current through R4. Yes or no? Okay, whenever we know that whenever current is passing, so current flows from positive to negative. There is a drop in potential. Again, direction is like this, positive to negative. Here, direction is like this, positive to negative. In this case, you see, in this branch, current is in the BC branch, plus to minus. In this DC branch, plus to minus. Okay, in this branch, you see already plus to minus is there. Right? So we have to prove using KCL and KVL. Apply KCL at a junction B. Apply Kirchhoff's current law at B. What is Kirchhoff's current law? Sum of all the current entering the junction is equal to sum of the current leaving the junction. Yes or no? So what is the entering current at this? That is I1 is entering. And what is leaving current? Ig and I3. So you can be write I1 is equal to Ig plus I3. Let's take equation 1. Similarly, apply Kirchhoff's current law at a junction D. At this point you see, apply. So entering current is what? I2 and Ig, that is equal to leaving current, that is equal to I4. Yes or no? So can we write that? I2 plus Ig is equal to I4. Let's take equation 2. Yes or no? Now you see this loop A, B, D, A. In this loop you see, apply the KVL. Apply Kirchhoff's voltage law in a loop A, B, D, A. What is Kirchhoff's voltage law? Sum of all potentials and EMF in a closed loop is what? 0. Okay. So you see in this loop A, B, D, A, this loop. So when you move from positive to here along the AB, what is the potential drop? You can see I1 into R1. Yes or no? According to the Ohm's law, I1 into R1. And sign, for sign, you can see the first sign. If you following the first sign, everywhere you have to take the first sign only. So plus current is what? I1, R1. Here you see in the branch BD, plus to minus. First sign is what? Positive. So plus current is Ig, resistance is G, so Ig into G. In the branch at DA, you see, okay, I2 into R2. What is the first sign? Minus. So minus I2 into R2 is equal to 0. Let's take equation 3. Similarly, you apply KVL in a loop BCDB. BCDB. Okay. So here you can see plus to minus. So plus sign you can go with. Current is what? I3 into R3. Here you can see in this CD now I4 R4. What is the first sign we are seeing? Minus. So minus I4 into R4. In this branch you see DB, minus sign is first. Okay. Ig into Z, current into resistance is equal to 0. Consider this as equation 4. So what is that? Now we know that when the bridge is balanced, okay, when a bridge is balanced, okay, so that time current through galvanometer is 0. Okay, use this Ig is equal to 0 in equation 1, 2, 3 and 4. So equation 1, you see, since we know that what is equation 1? I1, okay, is equal to what? Ig plus I3. So as Ig is 0, so what we can write? We can write I1 is equal to what? I3. Let's take equation 5. Similarly, if you use in equation 2, use Ig is equal to 0 in equation 2. What is equation 2? I2 plus Ig is equal to 4. I2 plus Ig is equal to I4. Ig is 0. So what we can write? We can write I2 is equal to I4. Let's take equation 6. Similarly, you put Ig is equal to 0 in equation 3 and 4. So using Ig is equal to 0 in equation 3 and 4. That can be modified. You can see what is equation 3? I1 R1, okay, plus I1 R1. Okay, this is 0. So plus Ig into G is what? 0. Minus I2 R2 is equal to 0. Okay, so once you move right hand side, I2 R2 become plus right now. So we can write I1 R1 is equal to what? I2 R2. Let's take equation. This is 7. Okay, similarly, in this equation 4, you see I3 R3 minus I4 R4 minus Ig into G. Ig is 0 means become minus 0 is equal to 0. Okay, so once you move this right hand side, so what we can write? I3 R3 is equal to what? I4 R4. Let's take equation 8. Now divide equation 8 by 7. Okay, so we can write divide equation 7 by 8. So what is equation 7? We have I1 R1, LHS to LHS we can divide upon I3 R3 is equal to what? I2 R2 upon I4 R4. Now you can see equation 5 and 6. Equation 5 is what? I1 is equal to I3. Equation 6 what we got? I2 is equal to I4. So I3 is nothing but I1 right now. So we can write I1 R1. I3 is nothing but I1. So substitute the value. So I2 R2. I4 is nothing but I2 only. Yes or no? So using what? Equation 5 and 6. Using equation 5 and 6 we have used. Now you can see I1 get cancelled. So what we are going to get? R1 upon R3 is equal to what? R2 upon R4. Yes or no? Okay, so R2 we can move to the left hand side. R3 you move to the right hand side. So what we can write? R1 upon R2 is equal to R3 upon R4. This is the condition for balance in case of Wheatstone Bridge. I hope you understood this Wheatstone Bridge. Please practice the derivation. If you have understood, please like the videos, share with your friends, and don't forget to subscribe the channel. Thank you.